All right. Thank you very much, Melissa. Kevin, well done setting us up on the alfalfa topic for today. Thanks everyone online for being here today. I am very excited to kind of introduce and present and provide an overview on this project that a number of people have been working on. So the title of the talk is actually the title of a research proposal that we submitted to the Dairy Innovation Hub last fall through their short-term high impact grant program. Long story short, research team gets a year to go and do a thing in the field and come up with some pretty impactful results. And so we were lucky enough to be awarded with some funds to do this work. So really what we're going to be focusing in on today is looking at alfalfa nutrient uptake and alfalfa nutrient removal rates. So how much nutrients is being removed per 1 ton of alfalfa dry matter. Also, right off the top, like to thank co-PIs Dr. Marta Coleman and Luana Carras for their support in this project. Okay, let's see here. There we go. All right, so our game plan today, I'm gonna spend a fair bit of time just kind of walking through the background of where this project came from, what we're doing, why we're doing it, how we're doing it, and then I'll give you a quick sneak peek at some preliminary results. It is by no means going to be a thorough overview of all the information we've collected, but we only have 25 minutes to there today, so we'll take what we can get. And then I'll leave you just kind of with what our game plan is on the project moving forward. And so why do this alfalfa nutrient removal assessment project? Why are we doing that now? So rewind the clock um, back to last summer and last fall. A team of us here at UW were working through updating the corn and soybean grain phosphorus and potassium, soil test interpretation levels, P and K removal rates in those crops. So how much P or K per bushel of grain, and then ultimately the fertilizer recommendation rates for those two crops. So we were working through that, meeting with different stakeholders and partners and audiences such as those in the venue here today. And almost every time we gave the presentation where we updated these corn and soybean things related to P and K, it almost never failed. We would get a response such as, "Cool, when are you looking at alfalfa?" Almost like, copy that, great, that's all fun and fine and dandy. Let's talk about alfalfa. And sidebar, corn silage is another crop of interest by folks. So specifically when folks are asking us to, consider looking at updating or at least evaluating some of these nutrient removals and soil test levels and things for alfalfa, really where a lot of people were focusing was on potassium. A lot of sentiment from the last fall discussions and presentations, as well as the previous 8 years of my professional journey working at a soil testing lab in my previous life. A lot of folks that I would talk to and work with their soil test results that are trying to manage alfalfa fields are just struggling with potassium management, and specifically, folks that were trying to apply university recommended potash rates to either build or maintain soil test potassium, and they were just struggling to do so. And so there were some questioning as to whether these removal rate assumptions that are built into the UW fertilizer guidelines are still accurate or reflective of reality. So we'll cover more of that. And so I guess the answer of when are you looking at alfalfa, I guess that answer is now. Again, hat tip, shout out, and much appreciation to the Dairy Innovation Hub for their support. So we're going to go through here what is being done, how it's being done, and then also I really want to give a shout out to the who and where the work is being done. Um, so to kind of start off, early this growing season, 2026, prior to alfalfa growth really ramping up for the year for first crop, our project collaborators, partners, if you will, went out to the farm fields that were identified for the project and collected a 0 to 6 inch soil fertility sample. We were just trying to document current fertility status in these fields prior to rapid nutrient uptake by the alfalfa crop. So this is kind of a baseline soil test. Then the number two here. So just prior, about 3 to 5 days prior to the farm taking first, second, third, fourth, in some cases fifth crop later on here as the fall comes in. Our partners, the project collaborators, are going out to these farm fields and collecting alfalfa biomass samples at a 2-inch cutting height from a defined area. Some cases it's 3 square foot, 3.5 square foot, 4 square feet. Just kind of depends on the equipment that the partner has. And so by collecting that fresh biomass in a defined area, we are able to determine fresh yield per acre, if you will. So after collecting those alfalfa biomass samples, they're sent off to Dairyland Laboratories in this project's case, where we are getting that alfalfa tested for moisture content and total nutrient analysis. So phosphorus, potassium, calcium, magnesium, and a couple other secondary and micronutrients. And so then number four, once we have now dry matter yield and nutrient concentration, we can determine total nutrient uptake by that alfalfa crop on a per acre basis. And then, at least personally, most interestingly, we can look at alfalfa nutrient removal rates. So how much phosphorus per ton of dry matter was taken up, or how much potash per ton of dry matter was taken up. And those are some of the pieces of information that we need to evaluate the current university fertilizer recommendations. Okay, and then lastly, number five, what we've been doing along the way is compiling all of this data from across the study. We're trying to share things back with our project partners and host farms kind of on the fly. And we're evaluating some of the data as we go. But the one focus thing that we're really trying to do throughout this project in this on-farm research project is to have timely results sharing. And so we've got an effort where once all of the information comes back from the lab, say for first cutting, we compiled all of the first cutting alfalfa data, soil sample data, and created a field summary report and that we would send back for a particular farm and field. And so that report would show the field average, yield, nutrient concentrations, nutrient total uptake, and then nutrient removal rates. And it would also show their field averages right next to the whole project, the study-wide averages, if you will, just as a point of comparison to other alfalfa fields in the state. So just a quick snapshot of how we're doing this data collection, this sample collection. So on the left, you've got that black square there that's representing an alfalfa field. And then you see 3 little green squares randomly placed throughout. And those are identifying or representing those 3 random sampling points. So starting back at just prior to first crop being cut by the farm, the project partners, boots on the ground help here, went out and identified 3 subsample locations, and they either flagged them or GPS referenced them. And so every subsequent cut throughout the rest of the growing season, they would go back to those same 3 points and take that cutting sample. So we're collecting biomass from approximately the same 3 parts of that field all season long. And then just to note on the soil sampling, the preseason or the early season soil and the postseason soil will be collected the same way, where 4 cores are being collected around each of those 3 alfalfa sampling points. So 12 total cores being collected from across that field, and those are being mixed and composited and sent off to the lab. So the objective by doing some replication and spreading things out a little bit is to capture some real world variability in yield and soil conditions and nutrient uptake and so on. This is my favorite slide in the entire presentation. This really does a nice job showing how collaborative this project has been. I've been in the trenches behind the scenes on this project since day one, and it wasn't until I really started kind of mapping this out and putting some numbers together for for you all today that I just really realized how many different people and farms are involved in this project. So the stars that are on this map here, this Wisconsin counties map, what this is indicating is if a county has a star in it, that means there's at least one field, alfalfa field, being sampled as part of this project. Um, I counted these yesterday, 10, 15. There's 21 counties being represented in this project. So very wide geographic coverage. All right, so the kind of the breakdown here, we have soil and alfalfa samples being collected from 53 unique fields on 40 individual farms by 17 different people from 7 different organizations. Okay, so there's again a lot of moving parts and a lot of people involved in this effort. Of the 40 individual farms, 38 are real working farms. Uh, 2 are just pretend agricultural research stations that the university manages. I'm just kidding. So Ashley Blackburn and Mike Bertram, if you're watching, I'm just joking. 2 university farms also participating in this effort as well. So again, a good variety of management, soils, environments, so on and so forth being represented. Of course, we've got university extension staff involved. This is our boots on the ground people. So extension staff, county land and water departments have folks out there, and a couple independent consultants from the state as well. Um, we have a formal partnership with the Wisconsin Alfalfa Yield and Persistence Program that Mike Bertram facilitates. I think they're in their 20th year, if I'm not mistaken. They're sampling alfalfa on a much larger scale where, say pick an alfalfa field. Every wagon or every chopper box, what have you, comes off that field is getting weighed. They're taking a grab sample from those wagons and sending that to the lab for forage quality in this WAYP program. This year, we've asked, hey, can we provide funding to have you add the nutrient analysis that we need to determine total nutrient uptake and all those things. So we've been able to partner with that program, and we're very thankful for that opportunity as well. And the last partnership I want to highlight, so Dr. Marta Coleman, Brian Luck, Francisco Arriaga, and probably a couple others that I ought to know off the top of my head have been working for several years doing a lot of research in the effect of machinery traffic, i.e. compaction, on alfalfa production. Again, these funds from Dairy Innovation Hub and this project are able to then support those efforts to get nutrient analysis tested from those research plots. And so they'll be able to look at the effect of machinery traffic and soil compaction on alfalfa nutrient uptake. And I think that'll be a really powerful add for them and for this project as well. So again, just thank you right up front here to all the different people and farms, host farms that are involved in this project. So all right, so that's kind of the quick elevator pitch overview of the project. I'm just gonna show a little bit some of the preliminary results. My disclaimer here, because the project is only partway through, everything here is subject to change, whether it's a number, an approach that we're taking to analyze the data, so on and so forth. This is very preliminary, and it's certainly not going to be a comprehensive overview of all the data. Today, we're just going to zoom in on potassium. So just step back a minute and think about how does this project tie into potassium management in alfalfa in general. So if we ask the question, what goes into an alfalfa K fertilizer recommendation today in Wisconsin? Kind of a 3-part equation. So the first step is having a soil test, and we interpret that soil test. And we're going to be looking at something very low through excessively high. All right. And depending on where that soil test K level is at, our approach to fertilization changes. And so in Wisconsin, we use a philosophy that has 3 different components. One is a build, where we're trying to build soil test levels from something that is low or very low up into that optimum range. We have a maintain approach. So if we're testing in that optimum range, our objective is to stay in that optimum range. And so we're going to fertilize really just that expected crop removal of potassium. And the assumption there is that if we just apply what the crop is going to use, our soil test level shouldn't change much. We should stay in that optimum range. And then if we're testing high or very high, we have a drawdown approach where we're still going to apply a little bit of potash or potassium, whatever your source is, but to a lesser extent than full crop removal, with the objective of slowly drawing that soil test level down into that optimum range. Okay, so soil test starts us off. Then the second piece is we want to have some realistic yield goal assumption being made. So is this a 2 or 3 ton system for the year? Is it a 5 or 6 ton across all the cuttings for the year? What do we think we're going to realistically get? And then what's really relevant for today is what I'm calling this K2O removal assumption. So again, how many pounds of potassium are we removing per 1 ton of dry matter yield produced? And so currently in our university guidelines, we have an assumption of 60 pounds of K2O being removed per 1 ton of alfalfa dry matter. Dr. Marta Coleman, co-PI on the project, has some other data from the state, unpublished preliminary kind of observational from the Prairie du Sac and Arlington areas, if I'm recalling correctly, where they saw these removal coefficients or removal rates ranging from 74 to 81, so a little bit higher than what's currently in the university guidelines. And this is specifically what we're really trying to address on the potassium end of things in this study is that assumption of 60 pounds of K2O per acre still reflective of reality on working alfalfa farms across the state? Because, and we'll come back to it later, this crop removal piece, so the yield times the amount of K removed per unit of yield, that's the single biggest chunk, if you will, of the total application rate recommendation. If we're trying to build soil test levels up, it's the crop removal piece plus maybe 30 to 45 pounds or 45 to 60 pounds extra. But that crop removal piece is a really big deal. It's a huge component. So it's in our best interest to kind of have a good understanding of what reality is. Okay. So diving into some of the relevant info to address that today, just give you an idea of the yield that we're seeing in the project. So from the first crop, we had 35 fields were sampled that we're including in today's data set. 114 total samples being represented here. The average yield, dry matter yield, was about 2 ton per acre. And I have this thing called the typical range. This is the middle 50% of the data. So across all 114 samples, the middle 50% yield range from 1.66 to 2.36. And so you can see the range. We have some lower yielding environments, some higher yielding environments. And I should also note that none of these are first year or seeding year alfalfa stands. These are all at least in their first full production year or older. I'll throw that out there as well. Second crop, as expected, we see the average dry matter yield a little bit lower than first crop, down to about 1.5 tons of dry matter with a range of 1.1 to 1.7. You'll notice that the number of fields and the number of samples included here are lower than from first crop. One of the realities with on-farm research is that you can make a plan and you think you're going to get out there and get your sampling done or your treatments applied or whatever the thing is, and then life happens. Reality on the farm happens. Schedules get busy. Communication breaks down. We're not going to cry over spilled milk. This stuff happens in on-farm research. So we missed a few sampling windows before the field had to get knocked down and hay had to get made. So that's why those numbers are a little bit different. Okay. So diving into this K2O removal coefficient, or these removal rates. Again, A2809 currently has an assumption of 60 pounds per ton. Looking at first crop, we see the average across all fields and samples, the average was 73 pounds per ton. And that typical range, again, that middle 50% was 63 to 82. Okay. For second crop, the average was 80 pounds per ton with a range of about 70 to 90. Um, and so, and then the average across both first and second crop was 75 plus or minus 10. Okay. So one other interesting thing that I'll note here, we're talking averages and these typical ranges and all that. One of the things that's commonly done, certainly in the corn and soybean world, when we're talking about these removal rates, um, but I think it's also happened in this alfalfa space as well, is that researchers doing this kind of work will use the what we call the 75th percentile of observed values when they publish or put a number into their recommendation system. So what that means, go ahead,
Chris, real
Melissa.
quick, 5 minute warning for you.
Copy that. Thank you. So what that means, if you look at that middle 50% number, that typical range of say 85 here in the middle, that is the 75th percentile, meaning 75% of observations have a removal rate below that, and 25% of observations in this project have a value higher than that. And a lot of times the justification for using that number rather than the average or some other lower number is to really avoid under fertilizing um, these valuable crops. So just wanted to kind of drop that out there. But nonetheless, it's looking like reality is a little higher than what's currently on the books. This will maybe not be a surprise to some folks. It turns out that soil test potassium is driving a lot of the variation that we see in these removal coefficients across the farms in this study. So what I've done here, you have soil test potassium on the horizontal axis and that potassium removal coefficient on the vertical axis. Um, that dashed horizontal line, that gray horizontal line at 60, again, is the university assumption of 60 pounds per ton. You'll notice there's a lot of observations above that 60-pound per ton line. And as soil test levels increase, that removal rate generally increases as well. So interesting trend that I thought I'd point out. And if we simplify that a little bit, if we take those soil test potassium numbers and put them into kind of grouped interpretation classes, so I put the very low and the low testing fields in one bucket here on the left. The optimum and high are all grouped together in the middle, and then the very high and excessively high on the right. And you can see that those average removal coefficients are in fact different between those soil test interpretation classes. And so I think there's a couple of things that we need to be considering, whether that's us as researchers, y'all as farmers or consultants, advisors to the farm. You know, the question that I'm asking and that we'll ask here internally as we continue going down this path is, should we be using different removal rate assumptions depending on the field soil test potassium level? Um, and to kind of maybe get at why we might do that is just a really quick walkthrough example. So what we're going to do in this little exercise, we have a 5-ton yield level, and we have 4 different removal rates, potassium removal rates along the top, ranging from 60, our current assumption, up to 90. This number, 300, 350, 400, 450, that would be the estimated total amount of K2O removed per acre at those different removal rates. And then below that is for loamy and sandy soils, the expected change in soil test potassium given that 5-ton yield and those different removal coefficients, that total K2O uptake. And so the point that I'm trying to make here, accurate assumptions of K removal in our fertilizer fertility programs is extremely important for managing K inputs. You can see that we could be seeing either a 46 or almost a 70 part per million reduction in soil test K in one season, depending on which number, what removal rate assumption we make. All right. And again, this crop removal is the biggest single chunk of a fertilizer recommendation. And so it's in our interest to at least be less wrong if we can be. So just wanted to kind of show you some of that as we kick this project off. So next steps, keep collecting data. and compiling everything. We'll get postseason soil samples to look at how soil tests responded to that crop being produced and any inputs that happened throughout the course of the growing season. Of course, we'll look at all of the other nutrients, not just potassium. We also are going to be asking the farms to fill out field and management surveys, so we can have all those other little nuggets of information that could potentially help explain what we see. And so, like I said, this project will formally wrap up at the end of the calendar year, and then there'll be a lot of outreach and conversations happening beyond there. So I just want to again thank the Dairy Innovation Hub for their support of this work. Dr. Marta Coleman and Luana again for their support behind the scenes. A huge thank you to all of the host farms that are allowing this work to happen. And then I wanted to leave on screen by name all of the people that are the actual boots on the ground, pulling these samples, maintaining those relationships with our host farms, making sure information is getting back to them or from them back to us behind the scenes. And so huge shout out to all of you. None of this would happen without you. So with that, thank you so much for your time. And I'm also happy to take any questions if we have any.